Hello. In this screencast, we are going to be exploring rotations and reflections of irregular polygons using GeoGebra. This screencast is designed for students in 8th grade. One of the standards covered is 8.G.A.1, which is verify experimentally the properties of rotations, reflections, and translations. Another standard covered is 8.G.A.3, which is describe the effect of dilations, translations, rotations, and reflections on two-dimensional figures using coordinates. So the big question we're trying to answer is, can a rotation and a reflection produce the same image? And this we're going to explore using irregular polygons. So I'm using GeoGebra in the coordinate plane because I want to explore how the x and the y coordinates respond to reflections and rotations. So first I'm going to create a polygon using the polygon function. So I'm just going to create a triangle. And I just want to come over here to the segment links to verify that this triangle is irregular. And we can see that they're all different, so this is an irregular triangle. And the first thing I want to do is I want to rotate this triangle 180 degrees. And I'm going to rotate it about the origin. So I need to put a point on the origin, which is 0, 0, and this is point D. So I'm going to rotate around point D. So I'm going to come over to this transformation function. I'm going to select rotate around a point. I'm going to select triangle and point D, and we're rotating 180 degrees. It doesn't matter if we choose counterclockwise or clockwise because 180 degrees rotation will produce the same image after each of those rotations. It would matter if we were selecting 90 degrees or 270 degrees. So I'm going to select OK, and now we have a rotation. And we can see that when we rotate about the origin, our x and our y coordinates change. And what happens is they become the opposite of what they were. So, for example, point A is at 0, 2, and point A prime, which is the rotation, is at point 0, negative 2. Point B is at negative 3, 1, and point B prime is at 3, negative 1. And you can see that this is the same for point C as well. So that's just the general rule for rotations, and this only works when you rotate around the origin. So what I'm going to do next is I'm going to create a line through point D, and it happens that this line is the x-axis. So I'm going to create this line through point D, and we have the x-axis, and it's the point y equals, the line y equals 0. So I'm going to come over here to this transformation function again, and select reflect about a line. Then select the triangle and select the line y equals 0, which is the x-axis. And now I have a new triangle. And this new triangle is A prime 1, B prime 1, and C prime 1. And we can see that A prime 1 has points at 0, negative 2, negative 3, negative 1, and 2, negative 1. It just so happens that point A prime and A prime 1 are both at 0, negative 2. But we see that B prime 1 is at negative 3, negative 1, and C prime 1 is at negative 2, two, negative 1. And since we've reflected about the x-axis, we know that our y-coordinate stayed the same, or we know that our x-coordinate stayed the same, and our y-coordinate became the opposite of what it was. So for example, point C is at 2, 1, and C prime 1, which is our reflection about the x-axis, is at point 2, negative 1. So our x-coordinate stayed the same, and our y-coordinate became the opposite of what it was. If we reflected about the y-axis, our y-coordinate would stay the same, and our x-coordinate would become the opposite of what it was. So we can see that this rotation of 180 degrees around point D and the reflection across the x-axis does not produce the same triangle. However, all three triangles are similar because their segment lengths are all the same and the area is the same. So let's try rotating 90 degrees or 270 degrees and see if that matches up with our reflection across the x-axis. So I'm going to come up here and select rotate around a point. I still want to rotate around the origin. And I'm going to rotate 90 degrees this time. I'm going to either need to stick with counterclockwise or clockwise when you do this, because if you mix them up, it's not going to give you the same result. So I'm just going to stick with counterclockwise. And we can see that that doesn't produce anything close to the reflection across the x-axis. So let's try again and do 270 degrees. And that's something on the other side. So that doesn't produce anything either. We know that if we did 360 degrees, it would just come back around to the original figure. So we can see that it's not possible for a rotation and a reflection to produce the same triangle. A triangle that would have the same coordinates after the rotation and the reflection.